Hey guys, today we're going to go over lesson 5. It says temperature, color, and sizes of stars. Now I'm going to be honest, this is one of my most favorite lessons, and I hate that I'm going to miss this with you guys because it makes me mad. I really enjoy teaching this lesson so very much. You will need some like color pencils. There should be some in the back. I'm going to try to leave them out for you guys, but you're going to need, if you can, and only for like a couple of minutes. So like if you can share with somebody, just share with somebody. You're going to need a red, you're going to need an orange, you're going to need a yellow, you're going to need a blue, and you should be good after that, okay? So go ahead, a red, an orange, a yellow, and a blue. If you have a pen or something like that, you can definitely use it for this because it's going to be easy. And matter of fact, I want to try my best because I need those colors as well. And I know yellow is always going to be the hardest one because there is no such thing as a yellow dry erase marker. So in its stead, when I use green, I actually mean yellow because there's no green. There's no yellow dry erase markers, okay? So when I use green, that means yellow. Yeah, so colors are kind of important to this lesson. Here we go. Temperature. So the first slide, like what do we mean when we mean hot? And unfortunately, what's hot to us as humans is really not even that close to being hot when we're talking to things about like about stars and things that are in space. And in truth, the opposite is also true as well. Like when we're talking about cold, we're talking about like temperatures that we can't even fathom. Okay, us here on Earth are kind of in a wonderful little happy warm bubble that keeps us, alive. But when we're talking about things that are hot, when we're looking at like a fire, what part of a fire is the hottest? It's not the same temperature throughout. I mean, there's videos of people walking across like ashes and coals and stuff like that. So clearly in a fire, there is some temperature gradient happening. Okay, so in general, when we're looking at like the coals, we're looking at temperatures that are around about 1,000 degrees. Okay, still sounds pretty bad. That's not fun to touch. The actual flame portion usually is pushing about 2,000 degrees. Okay, like the yellow flames. But what part is the absolute hottest of the fire? If you ever use like a blowtorch or seen like a jet engine or something like that, that blue flame that kind of comes out, that is insanely hot. That's around almost 2,800 degrees, almost pushing 3,000 degrees. Okay, really, really hot. So even in like a fire that you might have seen like in camping or in your house or something like that, there's quite a bit of a temperature gradient that's happening there. The same is also true for stars. When we are talking about stars, the first thing we can usually pick out is their color. So we have 5 different circles over here, and it's listed from hottest to coldest, and you do need to know these colors. So I'm going to write 1, 2, 3, 4, 5, and I'm going to be honest, this is one of the most confusing concepts for a lot of kids because the color that we typically use for hot and cold here on Earth are blue and red. And if I asked you in class, like, what temperature is cold? You're going to be like, blue. Okay, and then what temperature is hot? And you're going to probably say like red. Well, when we're talking about like extremely hot objects, if something is glowing blue, like I said, like we're talking about like a blowtorch, that is the absolute hottest. So the hottest color a star can be that we can see is going to be a blue star. That's the hottest star. Okay, we're actually going to leave the next one blank because the next hottest color is white. Remember what I said about me using green because I can't write it in yellow. But the next color is yellow, and I'm just going to write the word yellow in it. But you should color that in yellow. Yellow is right kind of in the middle. And as we start cooling off as a star, they'll start turning a little bit more orange. Not a lot of orange there. And eventually it'll become, the coldest the star can be is red. Okay, in general. So, and you will have a test question like which one of these lists the colors in order from hottest to coldest when talking about stars. Blue is going to be the hottest stars, then white, then yellow, then orange, then red. Make sure you kind of drill that into your head. Again, I know we typically use red on Earth to represent things that are hot, but when we're talking about stars, red is actually the coldest you can go. Okay, now you're going to have to give me a second because, I think you're going to watch my favorite video. This next video. Yay. Hottest to coldest. Okay, so here's a picture of a star cluster, you can clearly see that some of the stars are yellow, some of them are blue, some of them are large, some of them are orangey colored, some of them are red colored. This just really kind of highlights that they are using different types of fuel to keep themselves going, with like the blue ones being the hottest, and as they're burning through their fuels, they're becoming more and more red. It was very important for us to discover this. Now, there is a video in this slide that you absolutely must watch, and I would highly suggest watching it like twice. Like if I was in class, we would watch it 2 times, okay? I watch it so many times. I even put like the little QR code, so if you're at home and you're like, oh my God, what was that video? You can use your phone and it will pop up on YouTube, okay? Please watch this twice, okay? Because it's about to explain this chart that we're going to go through in just a minute. Matter of fact, let's pause right here, and I'm going to give you a couple minutes. It's not very long, but watch it like twice, okay? Go ahead and do that now. While I set up. Okay, let's come back. So we are going to talk about what's known as the HR diagram. You should have this in your workbook. Okay, it looks like a graph with like some globby areas in it, and we're gonna fill those spaces in. But we're going to talk about what the HR diagram is. So as in that video it stated, they basically take all of the stars and put them into a graph. Now I want to explain what we're looking at when we're looking at the y-axis and the x-axis. Down here on the x-axis, we are ordering them by temperature. Now, you have learned about Celsius and Fahrenheit, and those are temperatures that we typically use here on our planet. But when we're talking about extreme temperatures like insanely cold and insanely hot, we use a whole other scale known as Kelvin, and that's why we're going to put a very big capital K there for Kelvin. That's the temperature scale that we're using. Okay. And then over here on the left-hand side, on the y-axis, we're going to put absolute brightness. Now I know on this chart right here it says luminosity. Remember from lesson 4 I said absolute brightness is also known as luminosity. Matter of fact, I've never seen anywhere else where they don't call it luminosity except for in 8th grade science. Okay, but if you see that, make sure you're aware of that. When they say luminosity, they're referring to absolute brightness. Now, there's some tricky things about this graph that I want to make sure you're very aware of. First of all, right here in the middle, we're going to put a 1, okay? And then numbers that are less than this, we're only going to put 2 tick marks. We're going to put 10 to the negative 2 and 10 to the negative 4. And then we're going to go to 10 to the positive 2 and 10 to the positive 4. Okay, basically meaning that this right here is average luminosity, and these objects above it are brighter, and these objects below it are dimmer. Okay, so average brightness, brighter, dimmer. Again, positive 10 to the 4th, positive 10 to the 2nd, 1, 10 to the negative 2, and 10 to the negative 4th. Okay. Take a minute. I know it's kind of weird, but these are dimmer objects. These are brighter objects. Okay. Now the hardest part, this is the only graph I've ever seen in my life that does this. Normally when we're making a graph, we start with like a 0 over here and we increase going from left to right. But the thing is with this chart, we actually know what the absolute brightest a star can possibly be. And we actually start with that number first, which is around 40,000 Kelvin. So 40,000, write that number there. This is the hottest area over here, and we're going to get cooler and cooler and cooler going this way. About halfway through, I want you to draw a tick mark, and we're going to put 10,000 Kelvin. And then way over here, it should be like 3,500. And believe it or not, that's about the dimmest a star can be before it just stops doing nuclear fusion, the process that keeps it going, okay, that keeps stars bright. So 40,000, 10,000 is about in the middle, and 3,500. Now, you might be like, why is this that important? Well, the issue is that when you look at this diagram where 10,000 Kelvin and 1 meet, we're going to put a little dot right there. It should be close to the center of your graph. And the reason why this diagram is made this way is that the star that is located at 10,000 Kelvin and at luminosity or absolute brightness of 1 is our sun. Okay, our sun is smack dab in the middle of this diagram. Who would have thought? Okay, I didn't make up the diagram. This is actually, our sun is like halfway through its life. So you have on your diagram all these kind of like globs. Let's talk about what these globs are. So there's a group of stars that start off like way over here. And you can do little circles, and we're going to color them in a second. And it includes our sun, okay? And this kind of goes diagonally through the whole thing. And there's a whole bunch of them. This is actually what most stars are. So again, using our colors, starting way over here on the blue side. So some of them are blue. And then I'm going to leave some of them white. I'm not going to fill anything up. Remember, I don't have a yellow, so I'm going to use a green. So right around our sun, we're going to start filling some of them in green. Or if you have a color pencil, use yellow, because that would make sense. Use yellow. Then those yellow stars start turning orange. And then way down here at the end where they're getting colder and colder and colder. Let's say cooler. Let's not say cold. Cold makes it sound like they're turning into ice or something. They turn red. Okay. Most stars in the entire universe are going through this process right here. This is why we call this the main sequence. So if the stars that are going through this, including our sun, is a main sequence star. Okay, our sun a long time ago was blue and then white, and it's slowly turning more and more yellow. Eventually it'll turn orange and red. Okay, whenever a star starts using up all of its fuel, it has kind of two ways that it can go. Our sun, because it's not that big of a star, will join a group over here. And you could probably see this on the diagram, of kind of like some big red stars. We call these red giants. Red giants. Okay, this is where our sun will expand. It will engulf Mercury, Venus, and the Earth. That'll be the end of our planet that day when that happens. Okay, if it was a really big star on the main sequence, it actually will come over here and join these big groups right here. And we call these, this is an epic name for a star. If these are red giants right here, these are called red supergiants. It's like we let 5-year-olds describe these. Red super giant. Okay, these are like the really big stars. Now, for a couple, probably 100,000 years, our star will continue to burn through that fuel, and it will run out of hydrogen and start burning its helium. And at that point, it will turn into a blue supergiant. Blue. Now that it's burning helium, it's got to be a lot hotter. This is a bad day for our solar system. It'll become a blue supergiant. And eventually and quickly, it will burn away all of that hydrogen, and all that will be left is the core of the sun. And it will just sit there and kind of wither away. And this is pretty much the graveyard for most stars. They become white dwarfs. Okay. And still insanely hot, but very dim. They're very, very tiny. This is all that's left is basically the core of the sun. Everything else has pretty much been burned off by this time. And that would pretty much be the end of our sun's life cycle. Okay, well, what about these red supergiants? I mean, so let's back up. So our star started off as a blue main sequence star. It turned into a white main sequence star. Right now it's a yellow. Then it turned into an orange later on, then a red. Eventually it will expand in size, become a red giant, and then it'll burn up all of its hydrogen. Eventually it'll have to burn its helium, which will make it a blue supergiant. And then it will turn into a white dwarf, the end of our solar system. That's the end. Goodbye, kaput. Well, what about these red supergiants, these stupidly huge stars? Well, everyone else, you don't have to know this part for the test, but these are the ones that will either A, explode into a nebula, or do the opposite of explosion and compress into a black hole. And that's all we're going to talk about in regards to black holes and all that. I'm going to ask you don't have to know this part for the test. I just think it's kind of fun information. Let me find my clicker. So Main sequence star, again, the brighter stars are up here, the dimmer stars are down here. The hotter stars are over here, the colder stars are in this direction. When you look at this, red stars are very bright, but also very cold because they're kind of giant. Whereas blue supergiant stars are very, very bright and insanely hot. White dwarfs, not very bright, but still very hot. A red star on the main sequence is really, really dim and very, very cold compared to other stars. Yay, lots of diagrams. Yay, supernova. Okay, there's a practice problem. Hottest to coldest. Take a minute, look through those. You'll probably get that. Which of the 4 stars has the largest diameter? Take a minute, practice that one. Which star would be described as being the smallest, red, and coldest star? Okay, take a minute, look at this. If it was on the HR diagram, you should be able to get that. How is star A different from star D? I'm going to be honest, you'll see a test question very much like that one. The end of lesson 5. Tomorrow you'll have a practice activity that goes along with this, so be prepared to work with this. And that is all. Have a good day.